Yes, hello friends, welcome to the session, continuation of chapter 7, that is DC to DC converters. In this, the next concept is, I want to discuss what are the different types of choppers based on commutation. Okay, that is, types of choppers based on the commutation means you concentrate on, this concept is also called thyristor choppers. Thyristor choppers. This concept comes under thyristor choppers. Thyristor choppers. Thyristor choppers means the device in this chopper circuit is thyristor. We know that chopper is nothing but a DC to DC converter. Input is DC, output is DC. Supply is DC and device is thyristor means compulsory you can use the commutation circuit in order to turn off the thyristor. That's why the concept is given like this, types of choppers based on commutation. I told already, once we are talking about commutation means the device in the thyristor is semi-control device. One of the example is thyristor. Okay. Now, before starting, what are the different types of choppers based on commutation? First, I want to explain a small concept of load commutation or class A commutation. Then I will start with different types of choppers based on commutation. I told already, in the discussion of types of choppers based on commutation, in detail I will explain load commutation and forced commutation. In this concept, in parallel with the types of choppers based on commutation, I will also explain forced commutation methods and load commutation methods. Okay. Yes. Before starting this concept, first you write class A commutation. In this concept, first I am explaining class A commutation. Class A commutation. This class A commutation is also called load commutation or self commutation. It is load commutation. Load commutation. Why the load commutation? I will give load commutation. That is, this class A commutation, you know. What do you mean by commutation? The process of turn off of thyristor is nothing but a commutation. Then this class A commutation, it is also called self commutation. It is also called self commutation. It is also called self commutation. Load commutation is also called self commutation. Yes, tell. Then what is the circuit we can use for load commutation or self commutation or class A commutation? Let us consider the device we are using is thyristor. Let this is a thyristor is supplied . A thyristor is supplying power to the resistive load, but if you directly connect resistive load, for example, let us assume that a thyristor is supplying the power to the resistive load. Input is DC. Input is DC. Then if you connect like this, let the current to the load is I0. if it is connected like this, with this supply, thyristor is under forward blocking mode. Whenever triggering is given, the thyristor will start the conduction. When the triggering is applied, the thyristor will start the conduction. No doubt at all. Now, once it starts the conduction, then the purpose of using any semi-control device between source and load is to control the power. Yes, sir. But we don't allow complete on-off device. Completely we don't allow the turn on-off device. If you want to control the power from source to load means, you can make on and off control. Okay. First I trigger the thyristor. Then it's applying the power to the load. Then after some time you want to turn off. Then how this thyristor will be turned off? Don't think like this. Turn off is nothing but again you can switch off the supply. That is meaningless. Within milliseconds and microseconds, we want to make on and off control. Understood? Once thyristor will start the conduction, then no doubt at all it continuously supplying the power to the load. Then after some time you want to turn off this thyristor means, is there any elements are there to turn off this device? No. Then how to turn off this thyristor? Then for that purpose, after some time, in order to make turn off of this, it cannot be turned off by gate signal because it is a semi-control device. After some time, in order to turn off of this device, along with resistor, you also connect the L and C elements. Then we can form one RLC circuit and we can select that L and C elements in such a way that the circuit must be underdamped. In underdamped RLC circuit, the nature of the current is sinusoidal oscillation. Because of sinusoidal oscillations, based on L and C elements, at a particular instant current is 0. When the current in the circuit is 0, the current in the thyristor is also 0, then thyristor will be turned on. Understood? That is the idea behind developing the class A commutation or load commutation. Understand the concept what I am telling here? If you directly connect to the load without any elements, once you can trigger the thyristor, no doubt at all, it starts the conduction. But you don't allow continuous conduction of thyristor na. Why? Yes, you want to make control the power, convert the power, there must be on and off control. Once it starts the conduction, how it will be turned off? Is there any negative off cycle here? No. If it is a negative off cycle is present, then every negative off cycle thyristor will be turned off, no problem. But if input is constant DC, then how you can turn off this thyristor? One method to turn off this thyristor is use L and C elements. Then, now see, that's the reason why we are implementing class A commutation or load commutation. That this is thyristor. Along with load, we also connect commutating elements. This is a circuit we are using for load commutation. This L, C, R. This R is the load. This is low value of resistance. Low value of resistance. Let this current is I0. This is the thyristor. This load commutation circuit you can also draw like this. For high value of load resistance, this thyristor, this inductor, and we connect R and C in parallel. This is also load commutation circuit. This is also load commutation circuit. S, the supply voltage is Vs. This capacitance, resistance, inductor. This is also load, but it is high value of resistance. High value of load. For high values of load, R and C is connected in parallel to make the commutation. For low values of load resistance, R and C is connected in series. Where L comma C is the commutating elements. L comma C is the commutating elements. It is not a load parameter. These are commutating elements. Commutating elements. Where L comma C is the commutating elements. Then in load commutation, L and C must be selected in such a way that the circuit must be underdamped. L and C is selected in such a way that circuit must be underdamped. Circuit must be underdamped. Circuit must be underdamped. We can select L and C elements in such a way that circuit must be underdamped. Then what is the condition for underdamped? That is, R square is less than 4L by C. We can select L and C elements in such a way that R square is less than 4L by C. If we select R square is less than 4L by C, we know that in RLC circuit, the nature of the current is sinusoidal oscillations. Then what is the expression for current in RLC circuit? I equal to this. How we can write this I equal to, if there is no, let us assume that there is no initial capacitor voltage, then what we can write? Initial capacitor voltage Vs by omega L into e power minus zeta t sin of omega t. This formula you know. I equal to Vs by omega L into e power minus zeta t into sin omega t. This, what is omega, what is zeta, already given in RLC circuit. Okay. Now, based on L and C elements, what is omega here? Omega equal to square root of 1 by LC minus R square by 4L square. Based on L and C elements, at a particular instant, the current is 0. Current in the sense, this is the load current. This is load current. This is load current. That means, whenever thyristor is turned on, it starts the conduction. When the thyristor is turned on, it starts the conduction means, based on L and C elements, at a particular instant, the current is 0. When the current is 0 means, there is no current through the load. Once there is no current through the load means, there is no current through the thyristor. Then thyristor will be turned off. Understood? Okay. This is not a manual control. Then we can design the circuit in such a way that at a particular instant we want to make the turn off. At a particular instant we want to trigger the thyristor. We are designing the triggering circuit and we are designing the commutation circuit in order to make on off. Once we can control on and off means, then we can control the output voltage. Understood? Then that means in this commutation, we know this, in the case of RLC circuit, the nature of the current is sinusoidal oscillations. Then based on L and C elements, at a particular instant, current is 0. At a particular instant, current is 0. Based on L and C elements, at a particular instant, current is 0. At a particular instant, current is 0 means, then thyristor will be turned off. At this instant, I0 equal to 0. Once I0 equal to 0, then what the current to the thyristor is also 0, then thyristor will turn off. Thyristor will turn off. Then this type of commutation is called load commutation. Why the name is given as a load commutation? Why the name is given as a load commutation? That means in this commutation, by making the load current is 0, thyristor will be turned off. Hence it is called load commutation. That is, by making the load current is 0. How we are making the load current is 0? We can select the circuit is underdamped. That is, by making the load current is 0. Load current is 0. Load current is 0. Thyristor is turned off. Thyristor is turned off. Thyristor is turned off. Then it is called load commutation. Then it is called load commutation. By making the load current is 0, thyristor is turned off, then it is called load commutation. Then what is the application of this load commutation circuit? Yes, this load commutation is used in series inverters. This load commutation is used in the series. One of the application of load commutation is, what is the application of load commutation? The application of load commutation or self commutation is, it is used in series inverter. Series inverter. I already discussed series. What is a series inverter? How this circuit is used in the series inverter circuit. Okay. This about in detail about class A commutation or load commutation, or it is also called self commutation. Okay. Quick, note down. Okay. This about class A commutation or load commutation. Then we will start with another commutation, that is nothing but voltage commutation. But here I will discuss the voltage commutated chopper. When I am discussing the voltage commutated chopper, means that concept is also applicable for voltage commutation. That's why no need to remember separately for voltage commutated chopper and voltage commutation. Understood? I am discussing the voltage commutated chopper, means indirectly I am discussing the voltage commutation method. Understood? Okay. Then you write the voltage commutated chopper. Voltage commutated chopper. Alright, put siding. Voltage commutated chopper. This I am discussing voltage commutated chopper, means this concept is also applicable for voltage commutation, or class D commutation, or impulse commutation. Okay. Voltage commutation or class D commutation or impulse commutation. This voltage commutation is also called class D. plus D commutation is also called impulse commutation. That's why voltage commutated chopper and this commutation methods, the analysis is same, the operation is also same. Understood? Now, point to remember, this voltage commutated chopper, it is also called okay, it is also called classical chopper. It is also called classical chopper. Or it is also called impulse chopper. Or it is also called parallel capacitor commutated chopper or turn off chopper. Parallel capacitor turn off chopper. Different names I am giving. Parallel capacitor turn off chopper. Now see, first, what is the circuit for voltage commutated chopper or voltage commutation? Then how this thyristor will be commutated in this chopper? That process I want to explain. But whatever the operation I am explaining, that operation is not important for any objective point of view. Only for descriptive point of view only that operation is important. But after explaining the operation, whatever the formulas I will list out based on the operation and based on the analysis, that formulas are important for any commutative point of view. Okay. Okay. First you draw the circuit. What is the circuit we are using for voltage commutated chopper or voltage commutation? Once again I am telling, no need to remember separately for this commutation and chopper. Analysis is same. Even circuit is also same. Okay, this is the circuit we are using for voltage commutated chopper. So all of parallelly draw the circuit. This is main thyristor. This is a capacitor. Auxiliary thyristor. Diode. Inductor. We are supplying the power to the load. Here we are connecting freewheeling. This freewheeling diode. This diode. Capacitor. Switch. This main thyristor. Auxiliary thyristor. The supply voltage is Vs. This circuit we are using for voltage commutated chopper or voltage commutation. The I naught is constant. Positive, negative V naught. Where Tm is the main thyristor. the auxiliary thyristor. L comma C is commutating elements. S. Listen please. Then what is the operation of this circuit? Okay, during operation of this circuit, the assumptions are, let I naught is constant. That means we are operating this circuit is under continuous mode. And we are supplying the constant current to the load. With that assumption only, I am explaining this operation. Another one is, before starting the operation of this circuit, let us assume that already the capacitor start to a voltage of, charged to a voltage of, this is upper plate positive, lower plate negative, this is Vs. That means still I am not trigger main thyristor, I am not trigger auxiliary thyristor. Let us assume that already the capacitor charged to a voltage of Vs. So the doubts, sir, without triggering these thyristors, how this capacitor will be charged? That's why we are using this switch arrangement. Now first what I can do means, without triggering main thyristor and auxiliary thyristor, first what I can do, I will switch on the circuit. Whenever this switch is on, we are not trigger main thyristor, we not trigger auxiliary thyristor, then current will be flow like this because of the supply. Then capacitor charged to a maximum voltage of Vs, plus minus Vs. Then open the switch. Then remove the switch. Then switch is open. Switch is open. Okay, now tell me. Now the circuit is ready to operate. Now the circuit is ready to operate. Assumption is, assume that I naught is constant and assume that capacitor already the voltage is Vs with upper plate positive, lower plate is negative. Okay. Now with this assumption I am explaining the operation. I don't want to draw any equivalent circuits, all these, just you listen the operation, you remember that points. Okay. Then after explaining operation, whatever the points important, that points I will list out. Okay. Then I will draw the waveforms also. The same operation can be analyzed by using the waveforms also. In the waveforms also I will explain. Okay. Listen please. Now first I will trigger the main thyristor. Still I am not trigger auxiliary thyristor. Now what I can do means, first I will trigger the main thyristor. Tell me. When the main thyristor is triggered, then it supplies the power to the load. Yes. Whenever main thyristor is triggered, it supplies the power to the load. This is the direction of power supplied. Then it supplies the power to the load. Whenever main thyristor is triggered, it supplies the power to the load. Yes. Now the question is, when the main thyristor is triggered, is the capacitor is discharges or not? That is the first question. Yes. What do you mean by discharging of capacitor? Discharging of capacitor is nothing but a transfer of charge from positive plate to negative plate. Transfer of charge from positive plate to negative plate. When you transfer the charge from positive plate to negative plate, then the polarity will be reversed. That is the meaning of discharging of the capacitor. Yes. First we can check is the path is available for discharge of the capacitor or not. Yes, I trigger the main thyristor, it's supplying the power to the load. Okay, this process is continuing. Now, at that instant, whenever main thyristor is triggered, if the capacitor is discharges or not, that we want to check the condition. Yes, listen please. Yes, sir, the capacitor will discharges, and this is the path for discharging of the capacitor. This is the path for discharging of the capacitor. Like that you think. Yes, sir, capacitor will discharge. Whenever main thyristor will trigger, the capacitor will discharge, and this is the path for discharging of the capacitor. This is the path for discharging of the capacitor. Okay, this is meaningless. If you select this path, this is meaningless. Why? The charge is transferred from positive plate to again positive plate. That is mean. That's why this is not the path for discharging of the capacitor. Yes, it is not the path. Okay. To check, is there any another path is there for discharging of the capacitor? Yes. Whenever main thyristor is triggered, already capacitor is with this polarity positive and negative. Because of this negative, already diode is under forward bias condition. Then, yes sir, there is a path for discharging of the capacitor, and this is the path for discharging of the capacitor. Yes, this is the path for discharging of the capacitor. Yes, that means whenever main thyristor is triggered, the capacitor will also discharge. That means the main thyristor is carrying two currents. One current is load current, that is I0 current. Another current is discharging current of the capacitor. The capacitor is discharging in which circuit? LC circuit. In LC circuit, that capacitor is discharging. That's why, what is the current carried by this main thyristor? One is load current and other one is LC circuit current. But how much time the capacitor will discharge? The capacitor will discharge up to, this becomes, that is upper plate becomes negative and lower plate becomes positive. That is upper plate becomes negative, lower plate becomes positive. This is starting condition. This is second condition. Okay. Once capacitor is completely discharges, this becomes negative and this becomes positive. Then diode is reverse bias. Then the diode will reverse bias. Means it is under off state. Then only current, still thyristor is not turned off. Still thyristor is not turned off. Then only current carried by the main thyristor is which current? I0. That means when the main thyristor will carry two currents, at the instant of triggering of main thyristor, it carries the two currents. That means during discharging of the capacitor only it carries the two currents. Once the capacitor is fully discharged, upper plate becomes negative, lower plate becomes positive. Then only current carried by the main thyristor is which current? Load current. Still thyristor is not turned off. But don't think like this. Sir, this negative is connected here, then thyristor will be turned off. Even though this negative is connected here, but this positive is not connected across the main thyristor. Still this negative voltage will not appear across the main thyristor. Understood? Yes. Still it's applying the current to the load. Now this circuit is ready to turn off main thyristor. How the circuit will turn off the main thyristor? Now, in order to turn off the main thyristor, we can trigger the auxiliary thyristor. Yes. Whenever auxiliary thyristor is triggered, then it starts the conduction. Because of this auxiliary thyristor, this negative voltage is connected, negative plate is connected here, this positive plate is connected here, then main thyristor will be turned off. Once the main thyristor is turned off, now who supplies the current to the load? This operation is applicable under the assumption of constant current to the load. Who supplies the current to the load? Now auxiliary thyristor will supply the current to the load. That's why the maximum current supplied by the auxiliary thyristor is load current. Then up to what time it supplies the current to the load? Yes. Up to auxiliary thyristor is conducting. When up to what time the auxiliary thyristor will conduct? Again, the capacitor is changing its polarity. Na? Capacitor is changing its polarity means it transferring charge from positive plate to negative plate. Then it becomes positive. Then it becomes negative. Whenever it becomes positive and whenever it becomes negative, then automatically auxiliary thyristor will be turned off. Understood? Because there is no any capacitor current. Once there is no capacitor current means there is no any auxiliary thyristor current. Then auxiliary thyristor will be turned off. Like that only you can design the circuit. We want to make auxiliary thyristor will be natural commutation. Automatically it will be commutate. But don't think like this. To turn off this thyristor, we can use this thyristor. To turn off this thyristor, we can use another circuit. That is meaningless. That type of design, we can't. Understood? That's why we can design the circuit in such a way that the auxiliary thyristor will be naturally commutated. Okay. Whenever capacitor polarity becomes positive, negative, that again it comes to the same position now, first position. Then auxiliary thyristor will be turned on. But we want to supply constant current to the load. Already main thyristor is turned off, auxiliary thyristor is also turned off. But we want to maintain the constant current to the load means, again we want to trigger the main thyristor. Before triggering off main thyristor, who supplies the current to the load to maintain the constant current to the load? That means a freewheeling diode will supply the current to the load. Understood? Now, once up to what time freewheeling diode is conduct, whatever the energy stored in the inductor is there, that inductor energy is dissipated in the resistor, then completely freewheeling diode will turn off. When the freewheeling diode will turn off, again the circuit comes to the first stage now, then we can trigger the main thyristor. Once the main thyristor is triggered, capacitor will discharge. Now it becomes minus, this becomes plus. Then we trigger auxiliary thyristor. Once the auxiliary thyristor is triggered, main thyristor will turn off. Once the main thyristor will turn off, who supplies the current to the load? Auxiliary thyristor. Up to what angle this auxiliary thyristor will conduct? Again it becomes plus, again it becomes negative. Once it becomes plus and negative, auxiliary thyristor will be turned off. Once the auxiliary thyristor will turn off, who supplies the current to the load? Freewheeling diode. When the freewheeling diode will turn off, again you can trigger the main thyristor. Like this, the circuit will be controlled on and off, on and off. Understood? That's why this circuit is nothing but a commutation circuit. This circuit is nothing but a commutation circuit. Without this circuit, what is this chopper, you tell me? If the circuit is not there, what is this circuit? What is this chopper? Yes. One switch, one diode across the load. It's just like a step down chopper. But why it is called voltage commutated chopper? Externally we are using one commutation circuit now. Understood? Externally we are using one commutation circuit, but this commutation circuit is which commutation circuit? Voltage commutation circuit. That's the reason why this chopper is called which chopper? Voltage commutated chopper. Understood? I am explaining the concept here, how this circuit will turn off this thyristor. Understood? That means indirectly what I am explaining? Voltage commutation circuit I am explaining. That's why it may be voltage commutation or voltage commutated chopper. All the points are same. Understood? Okay. Now, but for any commutative point of view, for objective point of view, no need of any these points. If you want to write any descriptive point of view, whatever I explain, that you write by your own. But from this circuit, I want to list out, based on the operation, I want to list out some points that is very important for commutative point of view. Listen please, 1 minute. Every point is important. That means in this commutation, the thyristor is turned off because of a reverse voltage of capacitor. That means by applying the reverse voltage using capacitor, then main thyristor will be turned off. Hence it is called parallel capacitor turn off thyristor. and it is also called voltage commutation or voltage commutated chopper. That means main thyristor is turn off due to a reverse voltage applied by the capacitor. That is, by applying reverse voltage across the thyristor, by applying reverse voltage across the thyristor, reverse voltage across the thyristor, using parallel capacitor, by applying reverse voltage across thyristor using parallel capacitor, thyristor is turn off. Hence it is called voltage commutation. Now tell, the points important, and this is important points I am summarizing here. This you write as an analysis. Yes, tell. First point. What is the peak current through the main thyristor? The peak current through the main thyristor is load current and capacitor discharging. That is the capacitor discharging current. What is the capacitor discharging current? The capacitor is discharging in which circuit? LC circuit. In LC circuit, what is the peak current? That I already given. Concept of LC circuit. In LC circuit, what is the peak current? Let the initial voltage across the capacitor is Vs. Then what is the peak current in the LC circuit? Yes, Vs into square root of C by L. That is, first point is peak current through the main thyristor. Peak current through the main thyristor. Yes, peak current through the main thyristor. Peak current through the main thyristor. ITMP equal to I naught plus Vs into square root of C by L. Next, one more point. Tell, what is the peak current through the auxiliary thyristor? Peak current through the auxiliary thyristor. Every point is important. Peak current through auxiliary thyristor. Auxiliary thyristor. How much? ITAP equal to how much maximum current supplied by the auxiliary thyristor? Yes, this auxiliary thyristor is conducting in load only. That's why auxiliary thyristor current equal to peak value of auxiliary thyristor current is I naught only. It supplies maximum current of I naught only. Next, one more point. Tell, what is the peak current through the diode? Peak current through the diode. Peak current through diode. Peak current through diode. IDP equal to, I am not talking about freewheeling diode. This is the diode in this circuit. This diode is conducting in which circuit? LC circuit. Diode is conducting LC circuit. In LC circuit, what is the peak current? Yes, Vs into square root of C by L, because initial voltage across the capacitor is Vs. Now tell me, peak inverse voltage across the load, peak inverse voltage across freewheeling diode, that is equal to peak instantaneous voltage across the load. Tell me, very important. See, once again I am drawing this circuit. This is main thyristor. After discharging the capacitor, this is negative, this is positive, and this is the auxiliary thyristor, and this is diode, and this is inductor. Listen please. At the instant of triggering of auxiliary thyristor, whenever I trigger the auxiliary thyristor, once the auxiliary thyristor is conducted, at the instant of triggering of auxiliary thyristor. Once the auxiliary thyristor is conducting, at the instant of triggering of auxiliary thyristor, no other device is conducting. Now, freewheeling diode is under off state. Freewheeling diode is under off state. At this state, whenever auxiliary thyristor is triggered, main thyristor will be turned off. Now tell me, what is the voltage across this diode? Minus, this is supply voltage now. The supply voltage is plus minus Vs. Minus plus Vs, minus plus Vs. Apply the KVL for this loop. Minus plus Vs, minus plus Vs. How much? Aiding polarity or opposing polarity? Aiding polarity. Total how much? 2 Vs. That is minus plus Vs. That is 2 Vs. This voltage will appear across the field. That is this is minus, this is plus, this is 2 Vs. This is happening at the instant of triggering of which thyristor? Auxiliary thyristor. This is the reverse voltage across freewheeling diode na. The maximum reverse voltage across the freewheeling diode is nothing but a peak inverse voltage. That's why it is the peak inverse voltage for freewheeling diode. This is the peak instantaneous voltage across the load. That is peak instantaneous voltage across the load. Peak. This is one of the drawback of voltage commutated chopper. Peak instantaneous voltage across load. Voltage across load. That equal to peak inverse voltage. Peak inverse voltage across freewheeling diode. Across freewheeling diode is equal to how much? Peak inverse voltage across freewheeling diode is equal to how much? 2 Vs. It is at the instant of triggering of auxiliary thyristor. It is at the instant of triggering of auxiliary thyristor. Triggering of auxiliary thyristor. Auxiliary thyristor. It is at the instant of triggering of auxiliary thyristor. Understood? Okay. These are some theory points I am giving. Then I want to extend this concept. Some more points I want to do the analysis. In that analysis, remaining points analysis I will do by drawing the waveforms only. Then I want to discuss what is the disadvantage of this chopper. After that only, then we will start with the current commutated chopper, or it is also called class B commutation. Clear? These points you remember. Every point is important. What is the peak current? What is the peak current through auxiliary thyristor? What is the peak current through the diode? What is the peak instantaneous voltage across the load? That is the peak inverse voltage across the freewheeling diode. 2 Vs. Still, I want to continue in the next session by trying the waveforms of voltage commutated chopper. Then based on the operation, then based on that waveforms, I want to give some analysis. Okay. Clear? Concept.